Here are some other ways we can prove triangles congruent. Angle, side, angle, 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 side, and HL triangle congruent. So we learned about side, 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 and side, angle, side. So we're going to have 3 other ways you can prove triangles congruent. Yes, there's 2 homework assignments you're doing. It will be separate, yes. So, angle, side, angle. If 2 angles in the included side of one triangle are congruent to 2 triangles in the included side of another triangle, then the triangles are congruent. What this is saying, the included side is between the 2 marked angles. So you'll see that, do you see how this, like with the included angle, was between the 2 marked sides? It's kind of easier to see this. Do you see how if these 2 angles were to be pushed together, they would have the side marked in between it? You guys see that?
Yes.
This side is not between them, and that side is not between them. That's why this is the included side, again, because these 2 are not between them. Casey, you look confused. Okay. No, that's fine. So, if you're looking at this here, the angle is formed here, and the other angle is formed here. Do you see how both the angles share this side here?
Yeah.
So that's why that's the included side. Does that make a little bit more sense?
Yeah.
Okay. So it's the side that both the angles use to make part of their angle, if that makes more sense to you. All right, another way we can prove triangles congruent is angle, angle, side. So if 2 angles and their non-included side, so the side that's not inside of the 2, so not between the 2 marked angles, yes. You are not a loser.
Listen to how much of them
Okay, you're not a loser though.
I sit at lunch every single day.
Where?
In the choir room. And
That's
you
fine.
know what I do for almost the whole entire lunch? I sit by a piano and I just press on the keys. I can't really play the piano. I mean, I can, like, if I look at it, kind of can, but, like, it's not really.
That's sad. That's kind of.
Oh, Rob.
Sad?
I'm sorry, Rob.
That's kind of random.
Rob, is it because you don't have friends at your lunch, or?
I think it's that one, that I don't have friends in general.
I'm here. I have your lunch.
Yeah, but you sit next to a bunch of girls. Greg knows what's up.
Greg literally just said he's your friend and he would sit with you, and you just, that's
yeah,
the.
then come play the piano with me.
Alright, I will.
Okay. Alright, if 2 angles in the non-included side of one triangle are congruent to the corresponding 2 angles inside of a triangle, then the 2 triangles are congruent. So for example here, JKL. Do you see how they have an angle and an angle congruent and then a side congruent, right? Do you see how this side is not between those 2 angles? You see that or no? So this is angle, angle, side because the side is outside of them versus what we just talked about on the other one. So if it had been marked like this, do you see how the side's between the 2 angles? That is angle, side, angle. Do you see the difference between those 2? Do you guys see the difference between those 2? Hopefully, because they are different. They use the same letters, but in a different order. In angle, side, angle, the side is in the middle because it's between the 2 angles, right? In angle, angle, side, it's on the outside because it's outside the 2 angles. Does that make sense? I'm just trying to compare these 2 because they're very similar, right? The only difference is that the side is not between them this time. Does everybody see that now? Yeah.
Oh, sorry.
Do you have a question? No. Okay. If you do, just let me know.
So you're just raising your hand and secretly?
Finally, hypotenuse leg. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the corresponding leg of another right triangle, then the triangles are congruent. This is the only time that angle side side works. is if it's a right triangle. The only time that it works, when angle side side works, is when it's a right triangle. Because it forces that angle to be right, which then you know one of the measurements of the angle versus it just being congruent. So, this is called HO because a hypotenuse, which is the side opposite the right angle, and a leg are congruent. So these are called the legs. The hypotenuse is the one opposite the right angle. So that's called HL because the hypotenuse and a leg are congruent. And again, so they went A to B to D back around. So you need to do the same thing here. N to I to T. So make sure you're following that the same congruent sides and same congruent angles are congruent. We talked about that the other day. All right, questions there before we do some examples real quick. Okay. So we're using every single congruence theorem. State if the two triangles are congruent. If they are, use ASA, SAS, AAS, side, 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 or HL. Why I decided to change to side, side, side for that one, I am not sure. If there is not enough information, right, not possible. Okay, so letter A. Letter A. Austin, are those two congruent? So they're congruent by... Okay, can you give me the triangle congruence theorem? Triangle what? We'll make up this letter, PQR. I'm going to guess that that's R. Okay, go ahead. Is congruent to... Good. So he followed along the side that it was a single, then a double, then a triple. So he did the same thing here. Single, then double, then triple, right? So that's how you do that. All right, C is... Oh, not C. B. Are those congruent and by what, Hayden? They share a side, so what else can we mark in B? Can't we mark UT as congruent? So, do we have enough information now? Which one is that? Is the angle included or not included? So, which one is it? Side, angle, side. So, they're congruent by side, angle, side. What is the triangle congruent statement? I'm just going to do a couple of triangle congruent statements, too, just to get you guys used to that. Lindsay, what's the triangle congruent statement? You can just do one of them first. So just make a triangle from the first one. DU.
I can't see.
DU. Make it a triangle. DU.
I said R.
That's not an R.
What is that? I'm sorry.
That's a T. Is congruent to what triangle?
UST.
Which angle lines up with D?
S.
Okay, then.
U.
Go.
S.
D-U-T, and then you said S-U-T. That's right. Do you guys understand how to do those triangle congruent statements? Anybody confused there before we keep moving on? Logan?
Where's the T?
Do you guys have a different letter than I
No,
have?
it
It's a
looks.
T.
It's like cut
It's a
off
T.
a little
It looks
bit.
like a T.
Oh,
It
that
looks
is
like
a T.
lowercase r.
This is T. I see it on your paper now. It does look a little bit different on your paper. Does that make sense? I was like, I don't see it. All right. Daniel, is C congruent or not, and by what? There's not even two sides marked here, so be careful. They do share a side, right? Daniel? So they share that side. Is the side included or not included? Is between the two angles or not between the two angles? Look at it here. If you look at these two angles, is that line marked between my two fingers? Yeah, so it's between. So it's not angle, angle, side. It's angle, side, angle. And if I say triangle XKV, Kylie, what is that congruent to? So XKV is congruent to what?
B, W, X.
Yep. Okay, so you guys are pretty good there. So I'm going to stop with the congruent statements. I just wanted to make sure you were fine there. D, Greg.
Okay.
Do I know anything else that's not marked?
The right ankles.
We don't know that. They're not marked.
Vertical.
Yes, we do have vertical angles. Is that enough information yet? Is that enough information, Greg? That's 2 pieces. Is that enough information?
Yes. Right?
You need 3 pieces of information. Is there enough information?
No.
No, so this is not possible. No matter what the theorem is, you need 3 pieces of information, even for HL. Because hypotenuse leg, you need to know that it's a right angle. So you need to know 3 things no matter what. All right. Olivia, do you know letter E? You can use HL, or you could use, what else? You could use SSS. Because they share a side. But it is HL, hypotenuse and leg are here. And we know it's a right angle. So those are our 3 pieces of information. Or they share a side, so you could have used SSS. 2 things are true there. All right, next one. What corresponding parts must be congruent in order to prove that the triangles are congruent by the ASA? So what parts, so we're using ASA. So that means the sides in the middle. So what parts need to be congruent in number 1 for us to use that? Use ASA. What? At ASA means the side is in the... Do you guys see that the side is in the middle of the 2 angles? Stop. Guys, you see that the side is in the middle of the 2 angles? You guys all see that? So the side that's in the middle of the 2 angles is CD and CB. Okay, how about for the next one there, Devin? We know that there's not enough markings here. We can't do number 2 in order to use that one. So let's go on to number 3, Devin. What else needs to be marked there? Oh, wait, never mind. You can. Just kidding. Devin, you know that it's shared there, right? So that's shared. So what else needs to be marked congruent? Which angles? To make it angle, side, angle. So we have this angle and this side. So what's the other angle that needs to be congruent? What, we can't call it Y. There's 2 angles there. Give me 3 letters. Yeah, angle XYW needs to be congruent to angle. Perfect. All right. What's the other thing that needs to be marked for angle, side, angle? What's the other angle that needs to be marked for those to be congruent? Logan.
ABE.
And?
CB.
Good. So we know 2 lines are parallel, so they have alternate interior angles there. That's what they use there. We know that they share sides. So what's the other angle that needs to be marked congruent, Casey? What's the other angle that needs to be marked congruent for this to be angle, side, angle? Give me the 3 letters you think, and then I'll tell you where you're at. ABD is already marked congruent. So we need another one that would put the side in the middle. What angle would put this side between 2 angles? DAB is this one. Is that what you meant? Yeah. Is that side between 2 angles if you do that? So if it's those 2 angles, is that the side angle that it's between? Is that side between those 2 angles?
No.
No. So what's the angle that you need? That's what you just gave me. Yes. Start with B. Go to.
D.
Do you see how that's between those 2?
I said that.
you said you might have meant that, but you never said that combination of letters. So BDA has to be congruent to what, Casey? BCD is this one. Make sure B's in the middle. You want this one, right?
Yeah.
So B needs to be in the middle, so start at C.
DBC.
DBC, that's fine. That works. I'm taking it. All right, Kylie, what else needs to be marked congruent in number 5? For it to be angle, side, angle. So the side has to be between the two angles.
To be completely honest, I am kind of lost, so.
Okay, you have two angles and you're trying to prove it by angle, side, angle. Which, we're missing the side part of that. Do you see that? We have two angles marked but not a side.
Yeah.
So which side would be in between the two angles? Which side is touched by both angles?
TV
And?
and ST.
Perfect. I will always try to say it many different ways until you guys understand what I'm saying, okay? Does that make a little bit more sense?
Yes.
All right, and then finally, what is the angle that needs to be congruent? Remember, we're trying to prove by angle, side, angle, so we're missing an angle. What's that angle that needs to be proven there, Hunter?
BCA and BGC.
Okay. Thank you, guys. Let me get your 2 worksheets out to you.